Greetings friends, in this short video I wanted to show you how to use VassarStats.net in order to be able to compute t-tests. Here's the website for VassarStats.net. On the left hand side are the different kinds of statistical operations you can perform. We want this right here, the t-tests and procedures, and we want this first item here, two samples, t-tests for independent or correlated samples. So we're going to test for either independent or paired samples, sometimes it's called correlated samples. So you'll see, if you click on that, you'll see these dialog boxes come up. What I've done is just generated some random numbers, and in this instance they're going to be the pre and post test scores. So what we want to do is compare scores in the pre-test versus the scores in the post-test to see if there's a statistically significant difference between the two. So we highlight these scores here, copy them, and enter them into this dialog box. Make sure that the cursor is after the last number, not forming a new row, otherwise the computer will think that that's a new entry. And then we do the same thing here. Now, the next step is to identify which kind of a test we want to run. Since these scores are pre and post tests, they are paired in that way. So the person who scored a 67 on the first test scored an 87 on the second test. So we click on correlated samples and calculate. And down here, the calculations will run, and there's a number of numbers here that you don't need to pay attention to. The numbers that are significant are the numbers in the first row, which is the n. That means how many numbers were in each sample, 15. And then the mean score, the average for each column. And what we wanted to determine was whether or not these differences are statistically significant. So there's quite a gap there between the two. There's about 8.4 points between the two, but we want to know whether or not that result is statistically significant or the result of chance. The way to tell that is to take a look at the p-value. If the p-value is less than 0.05, then those differences are not attributable to chance, but that we say those numbers are statistically significant. For a one-tailed test and a two-tailed test, and another part of the course we talked about the difference between the two. If you talk about a pre and post test and the assumption is that the second instance the scores would be higher, then we would use a one-tailed test. And for this one-tailed test, the p-value is 0.04431. So we would say that since it's less than 5, those differences are statistically significant. Now I'm not going to run the numbers for a independent samples t-test. It would be the same process. You would put one group in sample A, another group in sample B. You would hit independent samples, and then the scores would be here. You do the same scores in order to be able to interpret the results.